Now, we go to steam utilization. Steam utilization, dalawa yan. May bilang sa power plant, steam. Pero naman, steam for the process. So, dito tayo mag-concentrate sa steam for the process kasi sa industrial tayo application. Okay? Yung power application. Dito, commonly is yung boiler at standard siya nasa common sa 100 PSI gauge. Pag nakita nyo yung boiler na 100 PSI gauge pressure yun. Okay? So, sa steam table, absolute na. So yun, there's a gauge. Tapos punta doon sa process. Ang process, meron tayong tanke na meron nakaanong steam heat exchanger. Ito naman, ini-inject yung steam. Ang next naman, steam kettle. Kettle, di ba kasi lutuan? Steam ang ginagamit. Ginagamit ito sa mga hinay-hinay lang. Tulad doon sa gatas, milk. Ang gatas at chocolate yan, kailangan steam para mahina lang yung pag-init niya. Ito naman sa mga heater, convection type heater. Kasi mga blower na may heater sa bagay meron yan. Dito sa atin, ang blower natin yung may mga malamig. Every point, kailangan may trap. Pumasok sa drain, yung mga drain yan. Pagkagamit lang ng steam, magiging ano siya, condensate. So, sabihin, kailangan mong i-trap yung steam. Lalabas is condensate lang. Yan. So, every point naman to, meron siyang mga vents, tapos meron siyang mga clips. So, what is the working pressure and the boiler and the mains? In the main, ito yung pipe na pinakamalaki. Where steam is generated as a source of energy for turbines or engines, the boiler pressure is usually high and often the steam is superheated. And the most suitable operating pressure for the boiler has then to be decided. It should be said that boilers operating at or close to their desired working pressure provide steam of best quality. Okay? Yung normal mo steam mo ng is 50 pesos, nag-order ka ng 100 pesos, sama na yun. Kailangan mo siyang i-reduce. Okay, yung boiler mo 100, i-reduce mo siya para makakuha mo yung best quality. Okay nga, maliit yung compute mo kasi malaki yung pressure, maliit yung unit mo, so hindi naman yung quality ng steam mo. Masacrifice naman yung quality of steam mo. So when the steam is to be used at a lower pressure, then pressure reducing valve or other control valves may be utilized close to steam using points. Yan, yung mga reheat coils, yung mga steam na plancha. So kailangan mababa ang pressure niya. Oh, wait. Nag-umpis na naman yung mga dati kasi meron itong animation. So yan. Nalis ko na yung mga animation. Ano lang yan. Kung storbo lang yan. Papagal. Yung pang-click. Diba? Noon kasi ano nila yung mga artistic yung pag-present. So, pagka yung uso na yung mga webinar, so hindi na masyado yung ginagamit yung mga animation. Kasi yung time, tapos hindi ka nakaka-advance reading. Okay? So, when steam for process use or for heating may then be supplied through pressure reducing valve or be available at pass out pressure from the engine or at exhaust pressure. So, in-point ng engine, merong mga iba-ibang pressure na pwede ka doon. So, kung doon naman sabi na kami outlet, so nag pressure reducing ka. So, in other cases where steam is wanted for process or heating use only, use of a package boiler, ang bibili nyo, di ba, yung mga Enertech, UKEP, mga Yorks brand, or sometimes a single pass water tube steam generator is almost universal. Yung package boiler 5 tube yun. Ito naman water tube, yung maliliit. Okay? Water tube type. Package 10. So the most suitable operating pressure for the boiler has to be decided. It should be say that boilers operating, so pag nabasa na to. So yan, kasi nga dito, animation. Okay, the steam load. Before selecting the size of a steam control valve, supply main or even a steam boiler, it is necessary to know at least approximately or better how much steam is supplied. So where steam is to be used as the energy source for heat exchanger, this is the same as knowing the heat load that is to be met. Almost all heat load fall into one of the two categories. Either some material is to be heated from a lower temperature to a higher one, or it is to be maintained at a higher temperature while heat is supplied at a rate sufficient to balance the heat load. Yan. Ito yung continuous flowing. Ito naman yung sa tangke. Sabihin niya, mini-maintain mo. Kinukontra mo yung losses sa wall ng tank. So in the first case, the amount of heat needed to produce the catching temperature is given by Q is equal to mCp delta T. Equation 1, where Q is the heat load, M is the mass of the material, Cp is the specific heat, delta T is the temperature rise. More usefully, since the steam flow rate is sought rather than the mass of the steam, Q is equal to Q over T is equal to mCp delta T over T, where Q is the heat load, T is the time available. Yung tanke mo initially at low temperature, increase mo sa time. Sa desired temperature, tawag doon heat up time. Yung time niya. Okay? Pero normally, ang pinupursue natin is yung heat losses. Kung alin yung mas malaki. Kung mas malaki naman yung heat up, so i-consider mo yung heat losses kasi. Yun talaga ang design sa tanke. Mini-maintain niya yung heat loss. Kasi pag yung heat up time, pwede siyang tumagal. 1 hour to 3 hours, 4 hours, hanggang sa mag-maintaining na lang siya. Kasi kung consider mo yung heat up time, ang laking load nun. Tapos, pag naabot na yung desired temperature, maintaining na lang siya. So, sayang na yung load mo, capacity. This is kasi require mo yun ng 1 hour, 30 minutes, kailangan ulit na. So, hindi yun sa gano'n. Pag lumaki ng tanke mo, so kailangan mo ling estimaten kung ilan yung heat up time mo. 4 hours, 6 hours, 24 hours, papandarin mo yun para mag-abot sa certain temperature. Pagdating doon, same capacity, same heat load, yun ang mag-maintain doon sa process. So, wala kang sayang. So, the steam load, then F H sub Hg is the enthalpy of evaporation of the steam at the pressure involved. So, ano yung pressure doon? M sub S equal to mCp delta T over H sub Fgt, where Ms is the flow rate of steam, H sub Fg is the enthalpy of vaporization, kilojoule per kilogram, or in English, BTU per pound. Yan. So, no formula yung steam. Yung enthalpy evaporation mo is yung desired dot side na pressure sa paggagamitan mo, hindi yung sa boiler. The second case is the supply of heat at a rate which balances the heat losses. And here, the heat load is given by Q1 is equal to UA delta T equation 2, where Q1 is the heat law, U is the heat transfer coefficient for heat law through the surface involved. Kilojoule per meter squared C hour. Delta T is the temperature difference across surface involved degree C. A is the area of surface involved, area of the wall of the tank. So example number 1, an air heater battery raises 2 cubic meter of air from -5 to 30 C. So yeah, continuous to. So case number 1 to diba continuous. So an air heater battery, mga series of heater na pare-parehas ang size or kahit iba, basta siya. Tawag dyan, same equipment, naka-series, ang tawag doon sa battery. Iba battery, pare-parehas siya. Pag iba-iba na yung equipment, naka-series, so hindi yung battery. Okay? Sa plumbing. What is the hourly steam load? So 6 bars gauge. Given the velocity B, the volume flow rate is 2 cubic meter of air from negative 5C to 30C. Steam gauge pressure is 6 bar. So required is the hourly steam load is equal to M sub S. Cancel mo nyo na o pieces lang to, di ba? So solution, M sub S equal to M times Cp times delta T over H sub Ft times T. So delta T is equal to 30 minus negative 5 is 35C. At negative 5C is equal to 268 Kelvin. Negative 5 plus 273. Steam pressure is 6 bar gauge or 600 kilopascal gauge or 701.3 kilopascal absolute of steam. Diba? 101.3 add mo 600. Ang the flow rate 2 cubic meter per second air at 101.3 kilopascal absolute of air. Solve for the mass. Mass equal to PBRT. So kaya nga absolute natin. So is equal to 101.3 times 2 over 0.287 over 268 is equal to 2.634 kilogram per second. So air is atmospheric. So hindi itong 6701. Bakit hindi 701? This is steam. So the air, galing sa atmospheric na usap kaya sa 101.2. So it becomes 2.64 kilogram per second. Dito yung consideration natin ng mass flow, atmospheric, and ang flow rate niya raises 2 cubic meter per second. Sabihin yung 2 cubic meter per second dito binabanggit. Diba? So tapos yung temperature mo negative 5 dito rin. So natin dito sa makuha mo yung mass. Yung mass constant na yan. So convert to per hour. This is now 2.634 kilogram per second times 2,600 seconds per hour is 9,482 kilogram per hour. And the Cp of for air is 1.0 kilojoule per kilogram Kelvin. So H of Ft is equal to 6 SF at 6 bar gauge is equal to 2064.7 kilojoule per kilogram. So sa isang table mo, hanapin mo 701.3 yun din yan. So Ms equal to M times Cp times delta T over H of Ft times T. So M sub S equal to 9482 times 1 times 35 over 2064.1 times 1 hour is equal to 160.7 kilogram per hour. This is the hourly steam load for 1 hour. Diba? Because ito 9482 is good for 1 hour. Nakikita niya. Yan. So example number 2. So case 2. Example 2. 1 pa rin. So required for ano lang to ng heating. A calorifier holding 2,000 liters is heated from 10C to 60C. So ito. Isa constant temperature. In 2 hours using steam at gauge of 3 bar, what is the hourly steam load? So meron na kasi 2 hours to. Kaya nga, kung meron siyang required sa 2 hours, so gagamitin mo against doon sa heat losses niya. So may insulation to. So pinong-compute mas mababa. So ito gamitin mo kasi specify na yung 2 hours. Walang yung mas malaki. Kung walang specify, walang standard na number, hookup time, pinong gamitin yung heat loss niya. So, malalaki. Swimming pool. So heat losses lang pinakonsider doon. So what is the hourly steam load given? 2,000 liters is equal to 2,000 kilograms. This is water. Diba? 1 kilogram per liter ang density. So 10C to 60C in 2 hours. This pressure diba? Required the hourly steam load, M sub S. So T is 2 hours. Cp is 4.187 kilojoule per kilogram Kelvin. 3 bars steam gauge pressure. S of Ft is 2132.6 kilojoule per kilogram. So steam tables. So M sub S equal to M times Cp times delta T over S of Ft times T. is 2,000 times 4.187 times 60 minus 10 or 50. Ulit, divide by 2, 152.6 over times 2 is equal to 98.2 kilograms per hour. Ito yung required na steam flow rate niya. Condensate flow, ganun din. Pasok dito. Tapos itong mga parts na yan, mga valvula na yan, tatandaan nyo yan lagi kung ano tawag niya. Itong mga relief valve. Kasi pag gumawa na kayo, hindi naman ito lang pupupitin nyo. Pag nag-ginawin nyo yan, kailangan kasama lahat yung accessories. Ano na yung mga fittings. Mga safety protection niya. Okay. So, example number 3. So, ito na yung case 2. A calorifier has a heating surface area of 2 square meter. Hindi ito case 2. Ano to? Yung heat transfer. And is required to heat a flow of water from 65 to 80 C. The U value has been found to 1 to 50 watt per square meter C. So, may design yung steam coil. And the steam can be supplied at gauge pressure of 2 bar in steam chest. What rate of water flow can be calorifier at that? So, given, so heating surface, so may design yung heat exchanger mo, kung makuha mo yung capacity niya yan. So, U is 1 to 50 watts per meter squared. So, parang case to kaya lang yung coil lang kinonsider. Hindi yung wall ng tank. Kasi ibang yung value nun. So, gauge pressure 2 bar in the steam chest. So, required flow rate. Required. Solution, a 2 bar steam gauge, saturation pressure A, temperature is 150.7. So, delta T, dahil itong equation mo, Q1 is UA delta T. So, dito, heat bus paroyo ang example niya, heat transfer. So, ilang. So, same application. So, ito lang ang heat transfer ang U. Pamunod natin, heat transfer area is yung coil. So, para makuha mo yung capacity ko, ang Q1 mo is UA delta T. Diba sa transfer. So, delta T is equal to T2 minus T1 over ln of Tsat minus T1 over Tsat minus T2 is equal to 18 minus 65 over ln of 133.7 minus 65 over 133.7 minus 80 is equal to 16.9 C. So, this is now Q1 is equal to 1 to 50 times 2 times 16.9 is 152,000 to 50 watts. Or multiply mo na 3.6. Okay, kasi watts to. So, para maging kilojoule per hour. So, this is 548,100 kilojoules per hour. Ito yung capacity ng heating coil. Okay. But ito kasi yung sample na. So, of equation 1, Q is equal to MCP times delta T is 548,100 kasi iniinit niya. Dito ang source of heat. So, itong Q magiging MCP delta T. So, M times 4.187 times 80 minus 65, so M is equal to 872 kilograms per hour of water. Okay? And then yung i-transfer to. This is now your answer. So, ito yung dito sa loob ng tanke. Flowing niya. Flowing. Next, sizing steam line on velocity. On velocity, based on velocity. The appropriate size of pipe to carry the required amount of steam at local pressure must be chosen. Since an undersized pipe means high pressure drop in velocities, noise and erosion, while a generously sized pipe is unnecessarily expensive to install and heat losses from it will also be greater than they need be. Steam pipe may be sized either so that the pressure drop along them is below an acceptable limit, or so that the velocities along them are not too high. Dalawang basis. Pressure drop, lagi naman. Pressure drop at velocities. Yung dalawang yan, lagi design basis ng sa piping. So it is convenient and quick to size short mains and branches on velocity, but longer runs of pipes should also be checked to see that the pressure drop are not too high. So ito, example to, piping, mayroon 30 to 50 meters interval, kailangan naka-slope siya. After that, i-drain mo yung condensate. Yan, trap. Yan. Hindi lang sa equipment, pag pumasok sa equipment, may trap on din sa piping niya. 30 to 50 meters interval. Streamline velocities, inline carriage steam, reasonable maximums. Okay, right. Okay, tama. For velocities are often taken up at up to 40 meters per second, 130 feet per second in larger pipes and at higher pressure. However, 25 meters per second or 80 feet per second may be more appropriate in middle ranges and even 15 meters per second or 50 feet per second with small size lines and low pressure. Okay. Sa PCM code, may makita naman kang ganito. Malapit ang value pero iba. Pero, so dito tayo muna. Iba ang makita pareha siya pero iba ang range. Doon pa rin ang range niya. Kaya dinis ko sa inyo. Tapos pag sa kukuha kayo doon sa isa. Ito na nga pinapakita sa inyong value. Okay? So SI, so carrying capacities of pipe may be read from a table of sizes and pressure. Or if the specific volume B is read from the steam table, then W is in kilograms per hour is 0.002827 B squared B over B, where D 5 diameter and mm, B is the velocity meters per second, B is the specific volume cubic meter per hour. Velocities higher than 40 meters per second or 130 feet per second may be accepted if the very large diameter line which some process of power industries use, especially when superheated steam is carried. So up to 60 meters per second or 200 feet per second on every one. So allowed dyan. Huwag malalaki na. Kasi outdoor na siya, so walang problema sa noise. IP units, velocity of situated steam in any pipe may be obtained from either table 1, SI of 2, IP. So ito yung figure. Figure 3 or calculated in feet per minute using the formula B is equal to 2.4 times Q B over A, where B is the velocity in feet per minute, Q is the flow in part per hour, steam. B is the specific volume in cubic feet per pound at flowing pressure. A is the internal area of pipe. So ito yung streamline velocities. Level 1, pipe time capacities at specific. Ito yung table. Ayan. Pipe time capacities at specific velocities in metric SI units. So pressure, ito yung velocity. So this is at ito mga standard sizes of pipe. Ito yung flow rate maximum. Flow rate at this pressure, at this velocity. Okay. So calculate mo na lang yan. Or gumamit ka ng formula. Ito naman sa generation, ano 14 pa. Ito naman sa English. This is for schedule 85. So, walang binanggit kung anong schedule. So, schedule 42. Dito, so ito mas maganda kasi meron ng capacity 85. Kasi iba ang magkaiba ang inch diameter. Yan, velocity, pressure gauge, ito yung value. Parang tumitigil nga selection. At the PSI, anong capacity mo at 120, anong capacity mo 700, so dito katitingin, so lalabas 2.5. Sa piping pa lang sa main. Daming mas yan. Schedule 80. So, steam piping for PRBs and plasmen. Ito yung PRB. Separator, condensate, so ito yung plasmen, no? Separate sa diba yung flash tank. Dito steam naman. Sa moist liquid yan, steam dito mag-reduce na. So velocity in piping other than steam distribution line must be corrected to sense. Dito naman, including pressure reducing valve and valve plus steam vent application. So ito is yung sa piping to, may maximum yan maximum yung makaka-design ka. So pwede mo siyang, tapos ito naman sa pakukuha mo dito, so dito lang to sa line ito, so pwede siyang lumiit. Pwede siyang palakihin. Kasi mahal kasi yung equipment na to, dapat sa nasa to na mabuti. Pwede siyang lumiit sa piping mo. Okay? Kaya yung common technique nila yun na para hindi na mag-compute same size. Yung problema, mahal yung equipment. Ayun pala, pag sinelect mo, maliit yung pipe. Yung inlet niya. Okay? So table P illustrate and look at steam properties. Steam tables lang to. Illustrate how the specific volume of steam increases as pressure is reduced. To keep reducing valve high and low pressure pipe velocity constant, the downstream pipe piping cross-sectional area must be larger by the same ratio as the change in volume. When downstream pipe size is not increased, low pressure steam velocity increases proportionally. Maliit, malaki. For best PRB operation without excessive noise, long straight pipelines must be provided in both sides. With piping reduced to the valve that expanded downstream gradually to limit approach in exit steam velocities to 4,000 to 6,000 feet per minute. A sizing example is shown in figure 1. So line velocity is, in figure 1 natin, is the velocity chart. Ito yung pipe size. So this is by table naman. By table, by figure. So double check mo to, double check mo naman dito. So itang ko muna ginagamit. Line velocity, so yan. Line velocity is also important in discharge piping from steam tap where two-phase steam condensate mixture must be slowed to allow some gravity separation and reduce carryover of condensate from flash vent line. Here, line velocities of flash steam should not exceed 50 to 60 feet per second. A much lower velocity must be provided for the separation inside the flash vessel by expanding its size. The flash load is the total release by hot condensate from all traps draining into the receiver. Figure 1 lists steam capacities of pipes under various pressure and velocity conditions. So ito heating system is 4,000 to 600 feet per minute. Process steam, so yung mga sauna, hindi yung heating. So, 8,000 to 12,000 feet per minute. So, dito, pwede yun sa power. Example number 4. Given a steam heating system with a 100 psi gauge inlet pressure ahead of the pressure reducing valve and a capacity of 1,000 pounds of steam per hour at 25 psi gauge, find the smallest sizes of upstream and downstream piping for reasonable quiet steam velocities. So given 100 psi gauge inlet pressure outlet is 25, capacity is 1,000 pounds per hour. Required the smallest sizes of upstream and downstream piping. So figure 1. So enter the velocity chart at A for upstream to. So upstream, meron kang 100 psi gauge. For 1,000 pounds per hour, go over to point B. Point B, ang pressure niya is 100 psi ito. Then, follow up vertically to C. Yan. So dito ka sa loob lang ng range to 4,000 to 6,000. So actual velocity at D, itong ano tayo na to, is 4,800 feet per minute for 1.5. Eksakto to, tumama lang ha. Pero pag dito ka sa baba, lumampas ka ng 1.5, so ang gagawin mo, select mo yung 1.5. Nagkataon lang na tumama to sa 1.5. So hanap ka ng pinakamalapit dito, sa B, tumama siya dito sa 2.5. So pag tumaas ka pa pala dyan, lalampas na sa range. So dito ka na. So 1.5 inch upstream piping. So yan. So double check mo rin. Yung una kasi, itong table is first selection mo. So dito, yung yung inlet. So next, downstream piping sizing. Enter the velocity chart of at A, still 1,000. Go to E, and 25 PSI gauge yung E. Then follow vertically to F. Dito, this is 2.5. Ang velocity mo is 5,500 feet per minute. So dito, so double check mo dito, capacity. So dito kasi may velocity, mayroon ka ng choice of velocity. So velocity mo 25, napag mo doon sa ano, sa 5 size mo, makuha mo. Tapos, di siya eksakto kasi minsan dito ka 300, pipili ka doon. So dito mas malinaw. So sizing on pressure drop naman tayo. Kasi kailangan ma-check mo yung pressure drop. And anything other than lines of only a very few meters in length, it is usual to choose sizes so that the pressure drop is not above, say, 0.3 bar per 100 meter run. So, yun tayo para dito calculation. Pag nagtrabaho na kayo, so ito mga reference dyan. Lahat naman ng process ng pipe sizing, pare-parehas. So, ito yung mga discussion natin. Diba yung mga pressure drop sa piping system. Na-discuss na din yan sa fluid mechanics. So dito yung mga parameters. So table. Sizing with greater flow rate in a given size of pipe and correspondingly higher velocities will increase the pressure drop in much more than linear proportion and can soon lead to the piping becoming quite unable to pass the required flow. So calculation of pressure drop in streamlines is a time-consuming task and requires the use of a number of somewhat arbitrary factors such functions as pipe wall roughness and the resistance of PT. To simplify the choice of pipe for a given load in steam pipe pressure, so figure 2 will be found sufficiently accurate for most practical purposes. So this is SI, steam pressure bar. So tapos dyan, kunin mo yung 10 PSI bawa, tapos 1,000 kg per hour. Then draw ka pa blind pababa, hanapin mo yung pipe size. So lalabas ang pressure drop mo andun. So kung maghahanap ka ng pipe size pressure drop, yung 1 bawa, 5 PSI, 1,000 kg per hour, hanapin mo yung 0.3 bar. So dito ka mag-set. So tapos hanapin mo yung pipe size. So this, ang standard pipe size, nabanggit na. So this is, yan. So kung dito, so nasa 65. ito eksakto sa 65 mm. Pag bumaba ka pag dito ka, bababa ka ng 65 mm. Pag hindi tumapat sa 50, so 65 ka pa rin. Pag bumaba ka pa, pag 48, so 50 ka na. Okay? So, parehas lang ito sa English. So, ito naman yung, in-indulge lang to. Yan, point B. So, pag essay, gamit mo ito. Sa English ito. Always check if the pressure drop is within allowable limit before selecting pipe size in long steam mains and whenever it is critical. So, figure 3 and 4 provide drops in schedule 40 and schedule 85. Yan. Ito, maganda itong isa na may schedule 40 and schedule 80. Use of the charts is illustrated in two examples. So ito wala siya. Pero schedule 40 lang yan. Standards. So ito. So figure P, this one is for 100 PSI gauge saturated steam. Ang figure for other pressure, andito ang factor. 60 PSI, factor mo is 1.5. Multiply mo itong value. Diba? So yung pressure drop, PSI per 100 feet, and steam flow in pounds per hour. Ito naman yung schedule 40, andito yung mga collection factor din. Yan. So example number 5. So yung dito sa figure, kitang factor dito. So yung multiply mo siya sa figure value. So kaya dito, sa example mo, babalik ka, i-divide mo siya. So, ng pressure drop. Pressure drop yan ha. For other pressure use, pressure drop kasi table. What will be the smallest schedule 40 that can be used if drop per 100 feet shall not exceed 3 psi when flow rate is 10,000 pounds per hour and steam pressure is 60 psi gauge. So given 3 psi per 100 feet, put a fit and 10,000 pounds per hour, steam pressure 60 psi gauge. Required, the smallest is schedule 45. Solution, step 1, find the factor for steam pressure in main. In this case, this is 60 psi gauge. 60, 160, ang factor mo is 1.5. So divide allowable pressure drop by factor 3. 3 over 1.5 is 2. So ito na gamitan mo. Enter pressure drop to PSI and proceed horizontally to the flow of 10,000 pounds per hour and select 5. Size on or to the right of this point. In this case, 4 inches. So alam mo yung 10,000 pounds per hour. This is now 2. So 4 inches. Tumama lang eksakto siya. Pero kung dito ka nagtapat, so that is 5 inches. Kung dito ka tumapat, still 4 inches. Okay? To the right. Example number 6. What will be the pressure drop per 100 feet in an 8 inches schedule 40 steam main when flow is 20,000 pounds per hour and steam pressure is 15 psi gauge. So given naman is a pipe size, schedule 40, so 20,000 pounds per hour, steam pressure is 15 psi gauge. So the required is pressure drop per 100 feet. Solution, enter schedule 40 chart 20,000 pounds per hour. Asan yung 20,000 pounds per hour? This is 10,000, this is 100,000. So ito, ibig sabihin is 20,000. And 8 vertically upward to 8 inches. And 4, 5, 6, 8, 10. So yan. Then draw a line. Papunta dito, ang labas is 0.1, 0.2, 0.3. So this is 0.23 PSI per 100 feet. So this would be the drop if the steam pressure were 100 PSI gauge. Since pressure is 15 PSI gauge, the correction factor must be used. So, number mo yung 15, the factor is 3.6. So, yung value mo is 0.23 times 3.6 is 0.828 PSI drop per 100 feet for 15 PSI gauge. Yan. Ito yung answer mo. Ayun na. So sizing superheated mains, yan is saturated. So when sizing steam mains for superheated service, the following procedure should be used. So divide the required flow rate by a factor in table 4. Ito yung factor, ito. Table 3, table 4, yung mga factor na yan. This will give ito table 4. So superheated factors, steam correction factors. So the total steam temperature in degrees Fahrenheit, hindi ito superheat na kung ano yung talaga yung temperature mo. So saturated combination, 20 PSI, ang saturated niya is 259 Fahrenheit. So at 420 limbawa, so this is 0.97. So di-divide mo yung flow rate. So this will give an equivalent saturated steam flow. Now, so enter figure 1. So steam velocity chart to select appropriate pipe size. If unable, then use the formula to calculate cross-sectional area of the pipe and then tables 5 and 6 to select the pipe size which closely matches calculated internal transverse area. So pag hindi mo ginamit to, itong gamitin mo, table 5 and 6, schedule 5, 4, ito yung mga dimension ng schedule 45. So pinagamit sa ibang subject to. Sa likod ng Morse, meron din to. So ito naman sa schedule 80. Okay. So now for the steam traps, ito yung pinaka-importante sa steam piping. In practice, a steam trap has two separate elements. The first of these is a valve and set assembly, which can provide a variable orifice through which the condensate can discharge at such a rate as to match the rate of condensation in the equipment being drained. The second element is a device which will open or close the valve by measuring some parameters of the fluid, pitching it, and deciding whether this may or may not be discharged. The groupings then may be described as mechanical, which include both ball float and inverted bucket steam tap. Thermostatic, which will include both balance, pressure, and bimetallic elements. And the thermodynamic or disk pattern tap. So this is now in figure 17. So more discussion sa steam trap is a separate topic. Pero meron sa lecture, kasama yata. Pero mas marami ito pag separate natin. Dami kasing type. So these are other types. Yung mga types doon sa internet kinuha ko para mas malinaw. Ito yung mga available ngayon. Mga steam trap. So check nyo sa YouTube yung mga webinar dito sa steam trap, mga application. So many steam users prepare to draw up selection guide list such as the ones on in table 12. So example, table 12. This is table 12 dito 19. May mali, table 19, table 12. So this is table. Ito yung spinax ko. Ito yung type, float, thermostatic. Pwede siya sa boiling, brewing coppers, evaporator. So pwede siya dyan. Ito naman inverted bucket. Ito naman ano niya, acceptable alternative. Ang A, best choice. So yan. So yung ibang wala, so hindi siya applicable. Hindi siya recommended. Okay. So ito naman sa ibang reference, steam tap selection guide. First choice, second choice. So yeah. Steam freezer, heating equipment. Ang malaman nyo rin ito, hospital equipment, meron autoclave, sterilizer, na ginagamit ng steam. Diba? Fuel oil heating, meron bang storage tank, mga bunker oil heaters. Oo. Line heaters, tracing to. Tanks and bats, yan. Dami namin, di ba? Na equipment ginagamit ng steam. Steam trap sizing. Steam main drip trap shall be sized with a 2 times safety factor at full differential pressure. In most cases, they will be P-port size with low capacity orifice or smaller unless otherwise shown on the drawing, and these shall be located every 200 feet or less. 200 feet, 30 to 15 meters yan, or less. Kanina, pinakita ang drawing, di ba? Piping. Traps for steam tracing shall be 1/4 to 1 size. They shall be located every 100 feet or less. Mga rules yan, no? Radiator trap shall be type size. Wrist protection trap shall be 1 up to 3 port size unless otherwise noted. Yung steam ginamit ko sa mga freezer. So, para uminit yung mga door freezer niya. Traps for equipment training are size and equipment naman to. With safety factors that reflects the differences of the HVAC and process industries, such as variations in actual hydraulic head and material construction of tube bundles. A summary of this typical recommendation as follows. So, for HVAC industry, non-modulating control valve have trap selected with 2 times factor at full differential pressure. So, modulating control system with less than 300 PSI gauge inlet have trap selected for full load at 1 PSI differential provide 18 to 24-inch deep leg for condensated drain freely to 0 PSI gravity return. With deep legs less than 18 inches control manufacturer's representative. So modulating controls with greater than 30 PSI gauge inlet pressure and trap selected with 3 times factor at full pressure differential for all preheat coils and 2 times others for factor for others. For process industry, almost the same, pero lang dito sa last. Modulating control system have trap selected with a 3 times factor at full differential at full pressure differential. Ito yung quick guide to the sizing of the steam trap. Need to know, 1 is the steam pressure at the trap after any pressure drop through control valves or equipment. The leap, if any, after the trap. Rule of thumb, 2.31 feet is equal to 1 PSI back pressure approximately. 3. Any other possible sources of back pressure in the condensate return system. So that is condensate taken to a pressural tank. B. Local back pressure due to discharges of numerous traps close together into small size return. Number 4. The quantity of condensate to be handled. To plug pump, A. Measurement. B. Calculation of heat load. And C. Manufacturer's data. Safety factors. This factor depends upon particular applications. Typical examples being as follows. Ito, yung discuss natin kanina na times 2. Yung safety factor is 2. General with temperature control and modulating, kaya nasa binanggit dito times 3. So main drainage times 2. Storage heater times 2. Special heater times 2 sa mga sa HVAC. And placing line times 2. Ito lang naman ang times 3. Rule of thumb, use factor of 2 on everything except the temperature controlled air heater, coils, and converter and siphon application. How to use? The difference between the steam pressure at the top and the total back pressure, including that due to lift in after the trap, is the differential pressure. The quantity of condensate should be multiplied by the appropriate factor to produce sizing load. The trap may now be selected using differential pressure and sizing load. Example number 7. So a trap example number 7. A trap is required to drain 52 parts per hour of condensate from 4 inches insulated steam main, which is supplying steam at 100 PSI gauge. So there will be a leak after the drop of 20 feet. So given 22 pounds per hour for an isolated steam main yan, hindi yan yung piping doon sa trap. Ang high PSI gauge, the lift is 20 feet. Yung elevation ng equipment mo doon sa main. Solution, supply pressure is 100 PSI gauge, lift 20 feet or 8.7 PSI. Multiply mo siya ng 2.31. The differential pressure now is 100 minus 8.7 is 91.3 PSI. So the quantity, pag walang lift, so that is 0. Okay? Quantity is 22 pounds per hour. So main strainage factor is 2, so times 2. So therefore, the sizing load is 44 pounds per hour. So is a small reduced capacity thermodynamic steam tap will easily handle 44 pounds per hour load at differential pressure of 91.3. So example lang ito, dinagdag ko dito chart, models 501 to 504.0. So ito sa model 1, model 2, yan yung dito lang po. Ano yung 5016, dinagdag ko lang para makita nyo kung paano siniselect. So ito naman dito yung pressure difference sa baba. Tapos, pipili kayo tapos flow rate. Pag anong tinamaan dyan, pinakamalapit, yun yung piliin mong model. Okay? So, pwedeng hindi tumama to. So, hanap ka ng ibang model na tatama yung flow rate mo saka pressure difference. So, flow rate is the sizing load. Okay? So, this is the end of steam utilization topic.